So when we look at the double angle identities, so what we're going to do is, this is useful for us when we have a multiples of 2, right? So multiples of 2. So think of multiples of 2. So here are the identities. So for sine 2 alpha, so sine 2x or sine 2 theta, this is the equivalent of that. It's another way of saying that is 2 sine alpha cos alpha. That's only one identity for that. Now for cos, we have cos 2 alpha. Another way of writing that or expressing that will be this, or 1 minus sine squared alpha, or 2 cos squared alpha minus 1. And then lastly for tan, we have just one of them. So let's go ahead with the examples. So example number 1, given angle theta in a standard position with its terminal arm in quadrant 3. So it's giving us a little bit of a clue on where the angle theta is. It ends in quadrant 3, and its sign is negative 1/3. So when we look at the unit circle kind of looks like this. Okay, unit circle, it's in quadrant 3, so this is somewhere there. Angle in standard position in quadrant 3. This, oh, that's not quadrant 3. Quadrant 3. The sign is a negative, okay, which is true, right? So in quadrant 3, sign is negative here. And what we're going to do is determine the exact value of this trigonometric ratio. Sine 2 theta, tan 2 theta. So here we go. So what does it say by when we said sine 2 theta? Well, sine 2 theta, it means you're doubling up the angle. And then what's the sign of that when you double the angle, basically? That's what they're saying. So sine 2 theta, this is the same thing as saying 2 sine theta times cos theta. Okay, so that's the equivalent of that. Now, the thing about this is that, well, 2 is 2. Sine of theta is a negative 1/3. But the problem with this is we don't have the cos of theta, right? So how can we do this when you have the 2? We have the sine of theta, which is, we can replace by negative 1/3. Now we don't have this. So any suggestions?
Solve for the x.
Solve for the, for cos theta, right? And how do we solve for this?
X squared plus y squared.
Yeah, so we're gonna first figure this out. And how do we do that? We know, yeah? We can use the identity, sine squared theta plus cos squared theta equals to 1, right? So we know this. We know that the sine squared theta plus cos squared theta is equals to 1. So sine squared theta is going to be negative 1/3 squared plus cos squared theta equals to 1. It's going to be 1/9 plus cos squared theta equals to 1. Bring it to the other side and solve for cos theta. Okay. When we subtract this, we need to have the same denominator. So this 1 can be 9/9 minus 1/9. So it's 8/9. Okay. So the last thing that we're going to do is take the square root. Take the square root. But when we take the square root, there is a plus and minus component of that, right? There's a plus and minus. So cos theta is equals to plus minus root of 8 over 3. Okay. Now, the thing about this is, although we know what this is, okay, let's see what the question is. It says here, this angle theta that they're talking about is in quadrant 3. So if the theta is in quadrant 3, it should be, we're going to take the cos that's a negative only, right? So you can write that down. Since theta is in quadrant 3, element of quadrant 3, so therefore cos theta is equals to negative root of 8 over 3. Okay? Well, what did we do? That just solves this piece. Okay? As you can see, we don't have every information that we need right away, but there is a way for us to get all of the information first, and then now that we have all of the information, we can go ahead and figure it out. So from here, we're going to go back to this and we say, okay, that's going to be 2 times sine of theta. Sine of theta is going to be negative 1/3 times negative root of 8 over 3. So that's going to give us positive 2 root 8 over 3. Okay, well, here's an answer. Is there another way we can simplify that further?
Yeah, you could split the 8 into 4.
Yeah, we can simplify the root of 8, and we know root of 8. We know root of 8 is the same thing as root of 4 times root of 2, and that's 2 root 2, yes? So it's going to be 4 root 2 over 3. Over 9, yes. Going, because it's, yes, thank you. 3 times 3 will give us the 9. Okay, so now if we had to double the angle, wherever that angle is, it's going to be 4 root 2 over 9. Okay, so far so good. That was not bad. Like I said, we don't have a strategy for this, but we can figure it out with the identity. Okay, let's do tan 2 theta. Okay, well, what's tan 2 theta? Tan 2 theta, the identity is 2 tan theta. I'm just replacing alpha with theta over 1 minus tan squared theta. Okay. Do we have enough information to figure this out?
We have the sine and the cos.
Yeah, we have a sine and a cos, so that means we can find a tan, right? Okay, so how do you find the tan? So I'm just going to go over here on the side here. So it's going to be tan theta is equals to sine theta over cos theta. Sine theta, let's negative a third over cos theta is 4 root 2 over 9.
No,
Negative 8 over 3.
No.
Is negative
Oh,
8
hold on. Negative 8 over 3. What am I doing? Negative root 8 over 3.
Can we actually just break that up into negative 2 root 2 over 2?
Yeah, we could do that too. Yeah. Okay. Sorry, I got this one in the back of my mind. It's supposed to be that one. Okay, so now I can just leave it like that for now. I'll fix it later. Okay? Or if you want, you can go ahead and do 2 root 2. So this is going to be 1 over root of 8, and it's positive. Okay, leave it like that for now. Make it a little bit easier for us later, I think. Okay, so let's see. Do we have enough? Yes, we do. Okay, so it's going to be 2 times tan theta, which is 1 over root of 8, divided by 1 minus 1 over root of 8 squared. Okay. Let's see. It's going to be 2 over root of 8 over 1 minus 1/8. Okay, I'm going to keep 2 root of 8. I'll deal with that later. And I have 1 minus 1/8. That's going to be 8/8 minus 1/8, so that's 7/8. Okay. Now I can't cancel that yet because this is a root of 8 and then this is just 8. So what do we do? So it's going to be 2 root 8 times 8 over 7. Okay, so that's going to give us what? 16 over 7 root of 8. Okay, I think what we can do is we can go simplify that now. Okay, so this becomes 16 over 7 root of 4. Okay, I'm going to simplify this. I don't have to show all the work. Is it okay if I go 14 root 2? Yeah? Okay. Because this is going to be, there's a 2 in here, that times 7. So that makes it 8 over 7 root 2. And that's our, that is our answer. Is that okay? Yeah. Now let's take a look at example 2.
You don't need to rationalize it, you're just gonna just leave it like that?
Yeah, we can leave it like that. We can rationalize it. If it's, yeah, we can rationalize it if we want to. So let's do the rationalize because I'm totally out of room in here. If we would to, if you have room, then go ahead and write this down. 8 over 7 root of 2. How do we rationalize this? Yeah, so what we're going to do is we're going to multiply by root of 2 over root of 2. Right? Because the root of 2, if we multiply by root of 2, that will give us root of 4, which is 2. So this is going to be just 8 root of 2 over 7 times 2, which is 14. And we could go simplify that a little bit further. Okay, so divide by 2, so 4 sevenths. So 4 root 2 over 7. Yeah. if you wanted to rationalize it. So if let's say in a test or in the exam, and then you happen to see something like this, and then this is your answer, and you don't see this in the multiple choice question, it's probably rationalized, the denominator was rationalized. So you were in the right track, it's just that it's in a different form. Good. Okay. Example 2 is quite similar to that one as well. Example 2 and example 1 are almost the same. So it says here, given the angle theta in standard position with its terminal arm in quadrant 4. Okay, terminal arm in quadrant 4. So it would be somewhere around here, right? So cos is 2/5, which makes sense. Cos is positive in here, right? Cos is 2/5. What is the sine? We don't know yet, right? So let's go ahead and write this down. So sine 2 theta is the same thing as 2 sine theta times cos theta. So we got the 2, we got the sine. Somehow we gotta figure out the cos. So yeah, go ahead and figure out the cosine. I'll do the same, and we'll compare answers. Okay. So we have to use the identity cos squared plus sine squared is equals to 1. And then I came up with 2 possible solutions for sine. One is positive and one is negative.
The negative.
So which one are we going to take? Because this is in quadrant 4, so it better be in the negative. So it's going to be negative root 21 over 5. Is that okay? So 2/5 for cos, negative 21/5 for sine. So now we can go back to this one and use the information that we got. Okay, so I got sine 2 theta is equal to negative 4 root 21 over 25. Okay. So far so good. Now let's do cosine 2 theta. Okay, well, what are we going to do? Cosine 2 theta, we got a few selections in here. Okay, which one do you think is the best thing to use? Or does it matter? This one? 2 cos squared of alpha minus 1? Yeah, we could use that one, right? Or 1 minus 2 sine squared. We could use that one too. Yeah.
Why are there so many?
There's different identities, different ways you can write that. I'll talk about that later on, probably when we have a little bit more time. Because when you look at this, cos squared, you replace it by 1 minus sine squared theta. So you got the 1, and minus sine squared theta minus sine squared theta will give you 2 cos. Yeah, so it's the same. Yeah. 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 So certainly, if let's say we have just this part. If we have just this part, it makes sense to actually say 2 cos squared theta minus 1, right? Right? It makes sense to just use that one because we're already given that. But because in question A, we have this information, then we could also use the other version. Yeah. So why don't you go ahead and use this version. I'm going to use a slightly different version. You should come up with the same answer. Okay. So you probably tried that 2 cos squared theta minus 1, right? And I actually did 2 ways. I got negative 17 on 25. You got that? And then I did a different one, cos squared theta minus sine squared theta. Slightly different strategy, but we got the same thing. Okay, so I just wanted to so for the test, you're only going to pick one. But I just showed you two different ways, and it works. Okay, good. Let's take a look at this one. This one's example number 3 is slightly different. So they're separated. So sine of pi over 3 plus cos pi over 3. What can we do? Does that kind of look like this? Right? Sine theta, cos theta, but there's no 2 there. Okay? So write each expression as single trigonometric ratio. As a single trigonometric ratio. So we can write that as a single trigonometric ratio in this form. So I'll write it down here. We know sine 2 times pi over 3, okay, is equal to 2 times sine pi over 3 times cos pi over 3. So this is the one that we have, and that's 2 different trigonometric ratios, sine and cos. So if we were to just write it as one trigonometric ratio, you can see that we can divide both sides by 2. Okay, so that sine pi over 3 cos pi over 3 is equal to in terms of one trig ratio, it's going to be 2 pi thirds over 2. Okay, so 2 times pi divided by 3, so 2 times pi divided by 3 over 2. So this is just one trig ratio. It says here evaluate as well. Okay, well, can we evaluate that? Can we evaluate this piece? Sine of pi over 3. What is sine of pi over 3? Is going to be evaluate means what is the value? So sine pi over 3 is going to be root 3 over 2. And cos pi over 3 is a half. So that's equal to root 3 over 4.
I don't understand what just happened.
Oh, there's a 2-part question in here. There's 2-part question. Like you can think of it as like a part A, which is write it as a single trig ratio. Here, we had 2 trig ratios, sine and cos, right? So if we were to just write it as one trig ratio, it's either sine or cos, then that's sine 2 pi over 3. So this is the first part of that question.
And then you cancel
And
the
the-
2 on that side, and then that side you divided it by 2?
Yeah, so this is an equation, right? This is an identity. Now, if I can only see this part here. I don't have the 2. So to get rid of the 2 there, I had to divide both sides by 2, and the 2 cancels. This doesn't cancel because this is the doubling the angle. So now this part really is equal to sine 2 pi over 3 over 2. And that's just one trig ratio, which is sine.
Okay.
So that's the first part of that question. It's the 2-part question here. And then the other part is to evaluate.
I got that part.
Yeah. Means to find a value. Okay. Now let's see this one here. Can we write this as a single trig ratio? can see that this is going to be if you look at this piece, this is going to be 6 cos squared theta minus 3. We can factor out a 3. So we're left with 2 cos squared theta minus 1. So 2 cos squared theta minus 1, 2 cos squared theta minus 1, what can we replace it by? 2 cos squared theta minus 1 cos 2 theta. So this is the same thing as just saying 3 cos 2 theta. So this is like under one term. That's part 1, writing it as a single trigonometric ratio. The next part is evaluate. The word evaluate means what's the value, but we can't figure out the value here because we don't know what the theta is. We don't know what angle that is. So yeah, it says here evaluate where possible. This one here, you can't evaluate. So that stays like that. You okay? Oh, now we're gonna go proving. So proving the identity. What can we do? Which side should I work with? Left side and right side? Maybe the left side? Okay, let's see what the left side looks like. Okay, cotangent. Cotangent, I want to make sure that I'm gonna get something sine squared at the bottom. Cotangent is cos squared. No, there's no squared. So cos of x over sine of x. Okay. Now what about this one? Cosecant 2x. Cosecant 2x, what can we write that as?
1 over 2 sine x.
1 over sine 2x. Is everybody okay with that one? That's a reciprocal identity, right? Cosecant, the reciprocal is sine, and vice versa. Okay, well, where do we go from here? Well, sine 2x can be written as what? Cos x over sine x. Sine 2x can be written as 2 sine x cos x. And then from here, I can see the cos x will cancel that cos x. And I'm left with 1 over 2 sine squared of x. Yeah. And then from here, I have to write down left side is equal to the right side. Is that okay? Yeah. Well, that one's not so bad. Let's take a look at B. You want to try the B on your own? Okay, go ahead. Go try it on your own. Are you done? Okay, so I have one solution here. I'm working out the other kind. This. So this is one way. So I replace the cos 2x with 1 minus sine squared of x, and that worked out okay. I'm actually playing with another one. So instead of that identity, I use a different identity. This is the identity that I used this time. 1 minus this one. And then I ended up saying, okay, well, these become sine squared of x plus sine squared of x is 2 sine squared of x. And that cancels, the 2 cancels, we're left with just one factor of sine of x, cos of x, tan of x. Okay? So I got 2. Here I had 2 possible solutions, 2 possible ways. So got option 1 and option 2. Okay, so far so good. Did you have C? 2C? Oh, this one? Oh, yeah. Yeah. Okay, hold on. Oh, you're already there. This one doesn't work. Okay. Yeah, so you're working ahead, basically, right? You tried to work it out. Yeah. That doesn't work. I tried working it out, and it doesn't work. Because it's, yeah, I don't know. Maybe there's some typo there. No, they're not. It's not an identity. Okay, so this is what I originally had. Okay, well, don't look at this one because we're not there yet. So this is my my own personal booklet. It says here, double check the identity, because I tried working it out. As you can see, my erasures in here, it doesn't work. So there's probably something. This is probably not an identity. And I did check it. I did check this on Desmos. If I graph this and I graph this, it didn't give the same graph. So that means it's not an identity. Okay, so yeah. I was like thinking, sorry, I didn't understand what you meant by C. You're just working ahead. Okay, now go ahead and do letter D then. Now, you look at this one. Do you remember this piece? That's the sine alpha, cos beta, cos alpha. Yeah. So this is an identity that's an expanded version. We can rewrite that as sine of 5x minus 3x, and then sine of 2x, and sine of 2x is 2 sine of x cos of x. Yeah. That's a fun one. Okay. For the last bit, example 5, A and B. Okay. So the first part of what we're doing is proving identity, but the other part of this identity topic is using the identity to solve equation. Okay, so that's what we're really boils down to. Okay, it says here, solve the following equation. Cos 2x equals to 1 minus 2 sine of x. Okay, well, how can we make this, how can we fix this? Well, we know that cos 2x is, we have 3 different identities for that. Now this is the good time to actually pick the right one, because now we're actually solving. So which one do you think would be beneficial for us? What was that? Okay, I'll just go 1, 2, 3. 2? Yeah? Yeah, why is 2? Yeah, it creates only the sign, right? The sign. Oh, okay, let's go see, check that out. So it's going to be 1 minus 2 sine squared x. Okay. Now I can see that this is going to be some kind of a degree 2. Okay. Degree 2 because it's something squared. So the 1 and the 1 would cancel, right? Now I'm going to have a negative 2 sine squared x. And if I bring that on the other side, it becomes positive 2 sine of x equals to 0. Is that okay? Now I can see that they have a common factor. What I'm going to do is I'm going to cancel a common factor of 2 first. So I'll take out the factor of negative 2. Yeah. This one? Yeah. What we could do, like what I did was I put this to the other side. I could have put this to this side so that our leading coefficient is positive 2. Yeah, yeah, we could factor out the sine of x, yeah. Certainly. What I'm trying to do is just get rid of that 2 for a second. So divide by negative 2, divide by negative 2. So sine squared of x minus sine of x equals to 0. And this is probably what you're thinking about, right? There's a common factor of sine of x. So sine of x, sine of x minus 1 equals to 0. So this is a degree 2 trig equation. Now we're going to separate them and say, okay, where's the sine of x equals to 0? And where is the sine of x equal to 1? Okay, now I have to keep in mind that it's between 0 to 2 pi. So 0 to 2 pi. Whereas sine 0 here and here. So it's going to be 0 and pi. I can put the r for 0. And then what's the last one? Sine is 1. Sine of x is 1. It's going to be up there. It's going to be pi half. And these are the only three solutions that we have. So therefore, the solutions are 0, pi half, and pi. Is that okay? Now, let's see this one. So for last one, part B, here's a double angle. We can replace that by 2 sine of x cos of x minus cos squared of x equals to 0. Okay, so the 2's would cancel that. So we're left with sine of x cos of x minus cos squared of x equals to 0. I'll show you my strategy in here. So what I did here is that I see that although this is a quadratic equation, trig equation, we can't get rid of the sign. Can't. If we replace this with the trig identity, we're going to have a sine. Sine squared, but then we have the cos. So we can't get rid of one and then the other to make it purely sine or purely cos. Not for this one at least. So here's what I did. Oh yeah, what did you do?
Oh, sorry. Because I was wondering, you just move the cos and x over and then divide by cos. So you, like, couldn't you just move cos?
This over there?
Yeah, and then divide by.
What we wanted to do is, because this is still a degree 2, we want to factor it out. You know how like when we're solving quadratic equation, we can solve it by factoring so that we can say this times this is equal to 0. And then whatever this is, we'll make it 0. Whatever this is makes it 0. It's called a zero product property. So that would be, we'll get to something like that later in a second. You'll see. So what we're going to do is we're going to factor out cos. Okay, let's go factor out cos because I see cos here and I see cos there. So cos of x, and if I factor out cos of x, we're left with sine of x minus cos of x equals to 0. So this one is not bad, right? Cos of x equals to 0. We can solve that one for sure. Now over here we get sine of x minus cos of x equals to 0. So I'm going to ask you this. When is sine of x minus cos of x equal to 0? 45 degrees, right? So when you look at this one, if you have a root 2 over 2, and the other one's root 2 over 2, sine minus cos will be 0 over here as well. Negative root 2 over 2, negative root 2 over 2. Sine minus cos is equal to 0. Another way to see that is, where is sine of x equals to cos of x? That's the only time where sine of x and cos of x are equal to each other, right? So let's go ahead and figure those out. In the span of 0 to 2 pi, cos is 0 at pi half, 3 pi halves, so x is pi halves, 3 pi halves. That's for that. And these ones, where is sine of x equals to cos of x, that's when x is pi by 4 and 5 pi by 4. So these are our 4 solutions. Okay? Good. Well, that concludes the whole chapter on trig identities, solving trig equations. Those are the big 2 topics that we've done. Can we prove identities? Can we verify? Can we solve? Okay, so there's an assignment time for you. So certainly at this particular time, you have a variety of things to work on. Okay, so this is an absolutely a time for us to really see if we know everything and if we're ready for the test. You can work on that part, certainly. The other part that I was going to give you is this. So this one here is solving. Yeah, solving with solutions. Okay, so the solutions are in here, which is really, really nice. That's one possibility. So this is your option. You can work on that one. You can work on that one that I just showed you. Another thing that I'm going to give you is this one here. It's going to be a busy day for us. And that's okay. This is an identities practice too. We've seen that in lesson 7. We have the sum and differences of angles. Sum and differences of angles. Solution. Okay, so that's another piece that you can work on. And then there's another one, or. So if don't say you're bored, because you'll never get bored today. The other one is a review sheet. Now we'll give you a review sheet. Trig identities review. Now I don't want to give you the thing because it kind of has the answer. So I'll give you a copy of this one as well. Okay? And of course, I'm available to help you out if you have any questions with anything math or trigonometry related.